Good morning to all. I'm starting today's lecture and I want to share my PPT on your screen. Friends, can you able to view my screen well?
Yes, sir.
Thank you, Prajakta. Okay, friends, this is the last application we study in detail in last lecture. That is the application of the operational amplifier as a subtractor. This is the schematic diagram where the operational amplifier can be going to work as the subtractor. This is designed a circuit in which both the inverting and non-inverting inputs are used to reach the inputs V1 and V2 to the inverting as well as non-inverting input. There will be the negative feedback will be used, that is the output will be feeding back to the inverting input terminal through the resistance REF. There will be V1 is the one of the input which is measured with respect to inverting and ground. V2 is the other input voltage which is measured across the non-inverting and ground, and R1 and R2 are going to make the potential divider, though that is the voltage across the R2 is feeding to the terminal that will be the non-inverting terminal or the positive terminal. And according to this design, the last statement is the if R1 is equal to R2 is equal to R3 and RF, that is R1, R2, R3 and RF are equal to R, then V0, that will be the output voltage here observed output voltage, is the difference between two voltage, that is the V2 minus V1. V2 minus V1, V2 is the greater, V1 is the smaller, and the difference between them is visualized, it will be observed at the output of the operational amplifier, that is the V0, and such a this application will be known as a subtractor. Then friends, we are switching to the next application, and that application will be nomenclatured as a operational amplifier as a differentiator. See toward the nomenclature, that is the heading of the point, that is the op amp as a differentiator, means that we actually know that that is the operational amplifier is a personally differential amplifier. Basically it is differential amplifier, but the designing of the differential amplifier, it is operate used to response for the or used to perform the different operations of the mathematics, that will be the addition, subtraction, multiplication, division, as well as the differentiator, integrator, exponential, polynomial, trigonometrical, and so on, logarithmic, and on. It means that basically operational amplifier can be worked to perform different mathematical process, and while performing the mathematical process, basically the function principle of a differential amplifier it will be used, and hence this differential amplifier is used as an operational amplifier because it is used to perform the different mathematical operations. Okay, here this is the explanation, this is the diagram and principle where the operational amplifier will be acting as the differentiator. That will be the rate of change, it will be known as a differentiator. The rate of change of y with respect to t, that will be known as a dy by dt. that is the derivative change of y with respect to change change in time, that will be known as an dy by dt. That will be known as an dy by dt. Basically, friend, just wait for a while. जाऊन आलास? जाऊन आला? किती वाजले? 10:30 वाजले फक्त. 10:40. माझं एक अजून हाफ आवर. हो. करते. Okay. Okay, friends, here. Just we are discussing the operational amplifier, and operational amplifier basically used to perform the mathematical operations like the addition, subtraction, multiplication, division, exponential, differentiation, and integrator, and so on. Means here we are using the basically differential amplifier, which is going to nomenclature as the operational amplifier, because this operational amplifier can be used to perform different mathematical operation. Here we are discussing the operational amplifier as a differentiator. Okay, differentiation means here operational amplifier can be used to perform the rate of change of two physical quantity. Means that consider if y is changing with respect to t, for a while consider t is the time and y is the displacement. Then the rate of change of displacement with respect to time, it will be noted by a mathematical formula dy by dt. And dy by dt is the rate of change of displacement with respect to time, and that function, that physical quantity, it will be known as a differentiator. Like that, if we are going to calculate the rate of change of two different physical quantity with respect to each other, then we are performing the process of the differentiation. And here by the electronic process of the signaling, we are going to performing the process of mathematics. We know that in physics we are going to use different mathematical process, different mathematical operations like the trigonometric operation, integration, differentiation, and so on. Here, using differential amplifier, that is the one of the electronic circuit, we are going to perform the process of mathematics of the differentiator. Means here differentiation, operation of the differentiation can be performed by electronic mode, by electronic circuit, and that is the differential amplifier, or simply it will be known as an operational amplifier. Here, that is op amp as a differentiator, and following circuit will be shows how the operational amplifier can be used as a differentiator. Okay, means that this circuitry here it will be shown. Just I am taking the laser. Okay, see here, this is the design, or this is the electronic circuit where the operational amplifier can be used as a differentiation or the differentiator. We know that in operational amplifier there are two terminal. One is inverting terminal, that will be shown by negative sign. Other is the non-inverting terminal, it will be shown by positive sign. But here see keenly, the non-inverting terminal that will be connected to positive sign, it will be grounded. Means that non-inverting terminal is grounded, and we know that when the non-inverting terminal is grounded, inverting terminal acts as visually ground. Visual ground. We see the concept in last lecture. We see in detail the concept of the visual ground. Visual ground means it acts like the earth. Means it, that terminal will be acts how it will be connected to the earthing. It will be acts like that. Okay. See here. Here the input terminal will be Vt. Vt is the voltage at a time instant t, at a moment t. Means the for time, if we starting from the 0, that will be V0. If we measured at after 2 seconds, that will be simply voltage after 2 seconds. Means here Vt is the pulse. and that pulse is measured with respect to time. In how much second, how much the voltage amplitude, that will be the moment, means the voltage amplitude for a respective time, that is the Vp. See here, the inverting voltage, it will be connected to directly the capacitor. Here is the capacitor, and again the here feedback, we know that the process of the feedback is the process of injecting some part of the output, some fraction of the output again to input. That process of injecting some fraction of the output back to the input, that process will be known as a feedback. But here output voltage, that is the part of fraction of output voltage, is connected through feedback resistance capital R back to the inverting terminal, that will be shown by the negative sign, back to the inverting terminal. Then which feedback was produced? Which feedback was finding us? That is, there are the two types of the feedback. One is the positive feedback and other is the negative feedback. In positive feedback, that is the output and the feedbacking fraction, that is the input, are came in same phase, that will be known as a positive feedback. And in positive feedback, the amplitude addition will be formed. In case of negative feedback, that is the phase of input and output are 180 out of phase, एकमेकाच्या विरोधात असतील तर. इनपुट पॉझिटिव्ह हाफ सायकल मध्ये असेल, आउटपुट निगेटिव्ह हाफ सायकल मध्ये असेल, हाऊ मच फेज डिफरन्स वॉज ऑब्झर्वड हियर? 180 out of phase. And if the input and output came 180 out of phase, that feedback will be known as that is the negative feedback. And in negative feedback, we see that there will be subtraction, process of the subtraction of the amplitude will be performed. Here the output will be fading back to the inverting terminal, that will be shown by the negative sign. Means which type of the feedback was finding here? That is the negative feedback, because the that is the voltage which was connected at the inverting terminal, and the output are came out of phase, that is 180 out of phase, and hence the negative feedback was achieved here by connecting the output voltage back to the inverting input terminal. Okay, this circuit is very simple. That is RC factor is used, we know that is the, if the resistance and capacitor are connected in series, that circuit will be known as a time constant circuit, because that is the time, means the voltage amplitude across the capacitor will be depend upon e raised to minus t divided by capital RC. That is exponential quantity, that is the voltage across the capacitor, it will be exponentially increases with respect to time with the ratio minus t divided by R into C, where R and C are the magnitude of the resistance and capacitor respectively. Okay, it means that exponential e raised to time t divided by R by C is the time constant, and that time constant, it will be depend upon the series values of the resistance and capacitor. Here that is the circuit is started with the capacitor and ending with the resistance. Okay, and the feedback is connected back to the inverting terminal, means the negative feedback was achieved. If with the RC means the resistance and capacitor RC constant, if the negative feedback was achieved, the operation of the differentiation or differentiator was performed. डिफरन्शिएटर जर आपल्याला परफॉर्म करायचं असेल, डिफरन्शिएटर म्हणून आपल्याला ऑपरेशनल एम्प्लिफायरला जर यूज करायचं असेल, तर सर्किट मध्ये जरा बारकाईनं बघा. द सर्किट इज स्टार्टेड विथ द सी, एंडिंग विथ द आर, and output is connected back to the input, that is the inverting input terminal through resistance R. Means that which feedback was achieved? Negative feedback was achieved. And if such a circuit is designed, that circuit will be used as a differentiator. It is used to perform the mathematical operation of differentiation. Okay, see the simple equivalent circuit that will be shown in diagram B. In diagram B, this is the voltage, that is the voltage amplitude. It will be starting with the positive and the negative will be earthed or grounded here. It will be shown here. This is the grounded. Okay. Circuit will be starting with the capacitor, ending with the resistance, and output voltage, that is the V0 amplitude. It will be connected back to the inverting terminal through resistance R. And if the voltage is passing through resistance R, current is produces, and that current is here mentioned as the I. Capital I is the current. Here capital I is the current. Here the capital I is the current. See the see the operation, how it will be work as a differentiator. Differentiator, it means the rate of change of two physical quantity. For simplification, consider the displacement and time. If the displacement is changing with respect to time, that will be known as a velocity. V is equal to dx by dt. That is the velocity. And that velocity is a rate of change of displacement with respect to time. This operation is known, in mathematics, it will be known as a differentiation. See here, the input signal source of the voltage is the Vt, amplitude is the Vt, that is the voltage amplitude at a time instant of a t. We are measuring the time, and with respect to time, we are going to measure the amplitude, that is the Vt. Vt is connected to the inverting input terminal through the capacitor. Capacitor is the starting impedance, ending impedance is the resistance. Here, the non-inverting input terminal is earthed. Just I said that non-inverting terminal is earthed. If the non-inverting terminal is earthed, inverting terminal acts as the visual ground. Visual ground means visually it acts as the input voltage 0 volt. Means it will be acts as the earth. Earth means it will be also act like parallelly the ground. Okay. See here, friend. The negative feedback is given back through the resistance, that is V0 is connected back to the inverting input terminal through resistance R, and negative feedback is achieved here. Again, let Vt is the signal volt, that is the pulse. Signal means the pulse that will be measured with respect to time. Then, then the varying current will be passed through the capacitor. We know that if the pulse will be started from 0 to t, consider 5 seconds, it will be ranges, the time will be varying from 0, 0.5, 1, 1.5, 2, 2.5, 3. In this way, the time is varying. But with variation of the time, voltage amplitude is also varying. Voltage amplitude is varying, but across the capacitor it will be varies exponentially in time constant ratio. Means exponentially e raised to minus t divided by RC, where RC is the product of the capacitor and resistors, or the magnitude of the capacitor and resistor that will be connected in this circuit. Here C is the magnitude of the capacitor, that is the C is the capacity, and R is the resistance. It will be measured in terms of the ohm. Okay. From the equivalent circuit, I calculate करायचं आहे. आपल्याला माहित आहे golden rule, Ohm's rule वापरायचा, V is equal to IR. What about the I? I is equal to V is equal to IR. I is equal to V divided by R. Voltage divided by resistance. पण इथं काय आहे? इथं काय आहे? Time constant आहे, exponential आहे, and I is equal to C into dV by dt. But V is the voltage amplitude at the respective time instant t. इथं काय महत्वाचं आहे? टाइम इन्स्टंट महत्वाचं आहे. टाइम इन्स्टंट वाढला की एक्सपोनेन्शियली ते वाढत जाईल. उदाहरणार्थ मी तुम्हाला थोडस पेन घेतोय मी, लक्षात येईल. कन्सिडर दिस इज द graphical representation of the voltage amplitude with respect to time, okay, and voltage amplitude with respect to time across the capacitor, it will be increases exponentially as the time is varies. At the same time, voltage amplitude across the capacitor is varying, it will be changes. जसा जसा t वाढेल तसं voltage across capacitor सुद्धा वाढेल. We know that capacitor is the one type of battery. Simply it is one type of battery, but when it will be acts acts in mode of charging. There are the two mode of the capacitor. One is the charging and another is the discharging. Again charging, again discharging. And we know that in ramp oscillator, that is the in case of the ramp oscillator or the UJT as the relaxation oscillator, आपल्याला माहिती आहे आपण कॅपॅसिटरच्या अक्रॉसचं जे काही व्होल्टेज आहे ते एक्सपोनेन्शियली कसं चेंज होतं विथ रिस्पेक्ट टू टी आणि ते टाइम कॉन्स्टंट वर कसं डिपेंडंट आहे मायनस टी डिवायडेड बाय आर इंटू सी वरती कसं डिपेंडंट आहे ते बघितलेलं आहे आणि करंट अक्रॉस द कॅपॅसिटर इज इक्वल टू कॅपॅसिटी इंटू that is the change rate of change of the voltage with respect to time म्हणजे इथं काय होते बघा I is equal to C into D dVt V म्हणजे voltage at a time instant t त्याचं डेरिव्हेटिव्ह विथ रिस्पेक्ट टू टाइम dt त्यामुळे C इथं जरा बारकाईनं बघा मित्रांनो मी C कॅल्क्युलेट केलेला आहे सॉरी I कॅल्क्युलेट केलेला आहे I is equal to C into dVt divided by dt आउटपुट व्होल्टेज काय असेल रे V is equal to गोल्डन रूल वापरा V is equal to IR पण इथं कोणता फीडबॅक आहे निगेटिव्ह फीडबॅक आहे निगेटिव्ह फीडबॅक म्हणजे व्होल्टेजचं साइन काय येणार आहे मायनस येणार म्हणजे V is equal to काय येणार मायनस म्हणजे V is equal to मायनस IR येणार म्हणजे इथं V0 जर मी आउटपुट व्होल्टेज कन्सिडर केलं तर आउटपुट व्होल्टेज V0 जर कन्सिडर केलं तर मायनस IR आला I च्या ठिकाणी I ची किंमत वरची पुटअप केला मी राऊंड केले ती मायनस R इंटू सी इंटू डीव्हीटी डिवायडेड बाय dt सिंपली या रिलेशन कडे बघा आणि मला हे सांगा व्हॉट अबाउट द dVt divided by dt and here is the differentiation of the two quantities and which are that two physical quantities one is the voltage at a time t and other is the time t we are taking the differentiation of the voltage with respect to time that is the dVt divided by dt dVt divided by dt that is the rate of change of voltage with respect to time and that is the differentiation and here the differentiator that is the operational amplifier can perform the mathematical operation of the differentiation आपण जे डेरिव्हेटिव्ह काढतो साइनचं कॉसचं मायनस साइन such a type in this way in mathematical way we are taking the differentiation of the signal vt सिग्नल जो आहे आउटपुटला मला जो v0 मिळेल तो आउटपुटला v0 असणार आहे तो काय असणार आहे मायनस आर सी इंटू डीव्हीटी डिवायडेड बाय dt that is here we are going to perform the differentiation of the input signal thus the output voltage is the time derivative of the input voltage is the time derivative of the input voltage means here we perform the mathematical operation of the differentiation आणि म्हणून लास्टला एंडिंगला स्टेटमेंट आहे here in this way operational amplifier can work as differentiation or a differentiator. This question will be asked for the short note that is explain in brief the operational amplifier as a differentiator. किंवा explain in brief the working of the op amp as a differentiator किंवा explain how the operational amplifier can be worked as the differentiator. कुठल्याही लँग्वेज मध्ये क्वेश्चन येईल आन्सर एकच आहे प्रोसेस ऑफ डिफरन्शिएशन मॅथमॅटिकल प्रोसेस ऑफ डिफरन्शिएशन आपण कशी परफॉर्म करतोय ती आपल्याला इथे एक्सप्लेन करावी लागेल ओके फ्रेंड्स यू अंडरस्टँड इन वेल मॅनर फ्रेंड Dipti you understand in well manner the function of the differentiator or how the operational amplifier can be worked as the differentiator. You understand? Please reply.
Yes, sir. Yes, sir.
Okay, Dipti. Next operation, that is next and last application of the operational amplifier, and that will be the very interesting application. That is that operation will be against the differentiation, and against the differentiation, which application? That is the integration. That is operational amplifier is the integrator. Here, just I am taking the lesser operational amplifier. Op amp as an integrator, the following diagram will be shown. that is operational amplifier, how it will be worked as the worked to perform the process of the or the operation of the integration in mathematics. In mathematics we know that the sign of the integration that will be in this way. Here I will write here on a, PPT, that will be, this will be the integration side, and how that process will be performed by the differentiator, it will be shown here. This is the diagram A. Just we changed the place of the capacitor and resistance. In differentiator, capacitor is the starting and resistance is the ending. But here, see that the starting impedance is the resistance and ending impedance is the capacitor. Only the places of the capacitor and resistance are interchanged. If we interchange the place of the capacitor and resistance in a differentiator, we can fabricate, we are going to fabricate the, the design of integrator. Just replace the place of capacitor and resistance. Then other remaining diagram will be as it is, remaining designing will be as it is, keep as it is, only change the place of resistance and capacitor. Here the resistance is the initial impedance, the capacitor is the final impedance. Here output will be connected back to the inverting terminal through the capacitor. Here the current in differentiator, current is the differentiation, and in integrator, the current across capacitor is the integration. Just understand, it is very simple. Change the location, change the place of capacitor and resistance. Okay, see here. That is the operational amplifier working as the integrator, and here the output voltage is proportional to the time integral. Magashi derivation with derivative or the differentiation with respect to time होता. इथं काय आहे? That is integration with respect to time. That is, there are the two physical quantity again, that is the voltage and the time. And if we take the integration of the voltage with respect to time, that will be known as an integrator. That is the application, mathematical application of the integration. Here the diagram B will be shown, it will be simplified. The starting is the resistance and ending is the capacitor. Okay, see here the input current is the ideal 0 आहे का तर visual ground आहे बघा. इन्व्हर्टिंग नॉन इन्व्हर्टिंग टर्मिनल ग्राउंडला जोडलेलंच आहे, आणि नॉन इन्व्हर्टिंग टर्मिनल जर ग्राउंडला जोडलं तर इन्व्हर्टिंग आपोआप व्हिज्युअली ग्राउंड होतं, म्हणजे त्याचं व्होल्टेज आहे ते 0 होतं. आणि इथं मी थोडासा माझा व्हिडिओ मूव्ह करतोय मित्रांनो. Okay, see here, what about the output voltage? Output voltage V is equal to IR, आणि I काय होईल इथं सांगा. R म्हणजे फक्त कॅपॅसिटर आहे, आणि कॅपॅसिटरचा रेसिप्रोकल ऑफ द कॅपॅसिटर इट विल बी वर्कड एज द रेजिस्टन्स अँड इंटिग्रेशन ऑफ द IT. इथं निगेटिव्ह फीडबॅक आहे, निगेटिव्ह फीडबॅक आहे म्हणजे मायनस साइन आलं. V0 is equal to minus 1 upon C integration of I dt. And what about I? I is equal to V divided by R. आणि I ची व्हॅल्यू V divided by R पुटअप करा. टोटल रिलेशन काय होतंय बघा. जस्ट आय एम showing by the red pen what is the important relation. It will be the final relation. This is the final relation. That is the V0 is equal to minus 1 upon RC. RC टाइम कॉन्स्टंट मगाशी गुणाकारात होता, इथं आता तो भागाकारात आलेला आहे. that is the reciprocal process आहे, reciprocal process आहे. 1 upon RC integration of V dt. That is here integration of the voltage with respect to time, and integration of voltage with respect to time is the process of the integration. That is the process of the mathematical integration. Therefore, here the operational amplifier can be used as the integrator. It is used to perform the process of the integration. Okay. Friends, here we studied both the application of the operational amplifier as an integrator as well as the differentiator. Read in home. I am sending all the notes in your Google Classroom. Okay. Please first submit your final attendance because the time is hovering. Only 2 minutes are remaining. Please submit your attendance in chat box. If you have any confusion about these two application, that is the integrator and differentiator, then please ask me. I can rectify your doubt. Okay, please ask me if you have any doubts, you have any confusion in this both application. Sakshi, are you present here?
Yes, sir.
Okay, you have any doubt?
No, sir.
Okay, submit your attendance. Prathamesh, today you are present. Okay, Nikhil Patil,
Yes, sir.
you have any doubt?
No, sir.
Okay, fastly submit your attendance first and ask me if you have any doubt. Rupali, Rupali,
Yes, sir. हाँ
you
sir.
all submitted the attendance.
हाँ sir.
Okay, you if you have no doubts, then I will end the meeting. Prajakta,
Sir.
I will end the meeting.
Yes, sir.
Okay, friends. Have a nice day. Stay home, stay safe. Thank you. हे रेकॉर्डिंग पण केले असते.